Alright guys, what is going on? We are back for video number 5 in my series on how to make a mobile game with JavaScript. Now, I am super excited to do this video because we are about to start this random universe generator. And so here we have up here on the top, we wrote in our basic system data last time. And like I said, this array is not going to stay here. I just put that in there because it was just a test, really, so that we could demonstrate some of these universes or solar systems being drawn out on the system or the screen. Yeah, so the first thing I want to say is I added two functions here. One of them is called line distance, and the other one is getRandomInt. And these two functions, you should type them in. You just copy them down. These functions I actually didn't write, I just pulled them off the internet because I'm terrible at math, and this line distance one basically it essentially takes 2 points, an x and a y for both of them, and then it just determines the length of the line based on that. And we're going to need that because when we generate our universe, we're going to have to make sure that the solar systems don't spawn on top of each other and that they spawn like a reasonable distance from each other. And then this getRandomInt, basically it takes two numbers, a min and a max. And the idea here is that, if you pass in 1 and then 10, it's going to get you a number between 1 and 10. So, pretty simple. And the reason we need that is obviously because we want random positions. So we're just going to be getting random numbers. But once you guys pause and type this in, we're going to just jump up here and get started right away, actually. So the first thing I'm going to do is under this basic system data, I am going to start a new function and give it a name. We're just going to call it generate random universe, and give ourselves some space here. And then inside, this is actually going to take one parameter, and we'll just call this num of systems. So you can actually pass in the number that you want, or like the amount of systems that you're going to want to draw on the screen. And then the first thing we want to do in here is we're going to define a new array, and we're just going to keep it empty for now. But this essentially is what's going to hold all of our systems that we generate. So the first thing we want to do is, obviously, we want to run through a for loop because we want to know how many systems we're trying to add to this array. So obviously this is a number, so while I is less than that, we're going to run through this for loop, and for each iteration of this for loop we're going to say we're just going to make a variable and start a new system, and we're just going to make that equal to an empty object. And then we're just going to define a couple of other variables here, and we're going to do an x, a y, and a name variable. And so here we're dealing with obviously our x and y coordinates. We had our chord x, chord y here, so now we're going to be generating those two. And we may not actually do anything with name yet, but I'm just putting it in there because obviously you're going to want your systems to each have varying names. So now this will seem a little confusing until we actually finish it, but here I'm going to open up a do loop. And if you don't know what a do loop is, it's a little different from a for loop. Essentially what it will do is it'll run the code in the middle. It'll run it once no matter what, and then what it'll do is it'll check the while statement. And the while statement is essentially if the check inside this while loop is not met, then it will keep running this, and it will continue to run it until this is checked. So what we're going to do here actually is at the top of this do loop, we're going to define a new variable called collision, and we're going to set that equal to false. So as far as we know, at the beginning of this do loop, there will be no collision between the system that we're trying to make and all the other systems that are already on the screen. So then here, obviously we want to say we want to keep doing this loop if collision equals true, because if there is a collision, obviously we don't want it to use the values that it generated in this loop. So the first thing we want to do is we want to say, okay, we know that our first system that gets drawn, we should just put in the center of the screen. So I'm just going to make a quick if statement here. And we're just going to say if the system data dot length is equal to 0, meaning that this is obviously the first one. It must be because there aren't any others in there. So if it's the first one, we're going to set x equal to 0 and y equal to 0. And that just makes it so no matter what, the first system will always be in the center of the screen. And then, of course, any one we make after that, we want to randomly generate around it. So in this case, what we're going to do is we're going to say x will equal. In this case, we want to get a random number here. So we're going to get a random number. Now, in this case, we want integer values as well. And so get random int is only giving us whole numbers. So if you put in 0.1 between 0.2, it's not going to work. It's going to error because it's, well, I think it would error. I'm not actually sure what would happen. But it would definitely not work the way we wanted it to. So in this case, what we want to do is essentially this. I already have this value written down, but what we're going to do is we're just going to get a value between negative 200 and positive 200, and then we're going to take whatever value is generated and divide it by 200. So now what this is going to get us is essentially this is going to get us a decimal value between -1 and +1. And remember, with these values, it's a percentage of the game's width. So in this case, we're either going to be, the star system is going to spawn between negative the game's width and positive the game's width, and 0, 0 being at the center of the screen. So our box essentially is 2 screen widths wide, and that will be our box for now, but we can always change that number later. Then what we can do is we can set y and do the exact same thing. So it's literally going to be equal to the same thing. So this, writing this out twice is going to get us 2 completely different random numbers generated. Like I said, decimals between -1 and +1. So now what we need to do is inside of this, we need to open another loop. And this loop, obviously we can't name it I because we already have an I. And this is going inside of the I loop. So we need a new variable. So we're doing j here. And we're going to say while j is less than, and we're going to actually run through the system data now. And the reason we're running through the system data is because we want to make sure that these new values that we just got aren't overlapping systems that we already have in that array. So now what we want to do is we want to use that other function we have, line distance. And now line distance is actually going to say, okay, get the line distance, and now remember it takes 2 points. So inside of this it takes 2 points, and each point is an object with an x and a y value. So we're going to say, okay, x is x and y is y, being these 2 values that we just generated that would have gotten set here. So then that's our first point. Now our second point is, since we know that when we pass this into the system data, make that x, and then we know when we pass in the systems data, we're going to get it at that iteration, and we know that we would have set a coord x on that, and then the y, we know that we would have set a dot coord y on the y value. And now the sensitivity, we're basically just going to be checking to see if that number that we generate is less than 0.3, remember 30% of the width. So what we're essentially doing is making sure that these systems, from the center of them, they're each 0.3 away from each other. And so we're going to say, basically, if this value that it returns, this number, is less than that 0.3, then we want to set collision equal to true, because that means that it's too close. So we don't want them to use these values. So now collision equals true, and what happens is when it gets to the end of this while loop, it'll say, oh, collision equals true, well then let's go back and do this again. So it'll run this do loop again, and it will continuously run this do loop until it finds a point that is far enough away from every other system on the screen. And that's what this does. So then, of course, now at the end of this, obviously, after this finds the correct points, we want to say system data dot push, and we want to push in this new system, and we're going to define it as an object, and it's going to have a coord x value, and we're going to set that equal to our x, and then it's going to have a coord y, and we're going to set that equal to our y value. So now what we have here is we have an array, and then this for loop is going to fill that array here, this whole for loop, and in the middle it's just going to be checking to make sure that there are no collisions between any of this. So alright guys, well that's pretty much going to wrap up what I'm going to cover in this video, and for the next video we'll go over a couple more things to add to this, and then also testing it. If you guys know what you're doing here, feel free to test this out and try throwing in some systems there. Otherwise, if you have no idea, then just wait until the next video and we will definitely cover it. Definitely subscribe and like this video if you're following along with this series and you're really enjoying it. And also, if you have any questions, please leave them in the comments below, and I will get back to you on those. I appreciate it, and I will see you in the next video.